Great. So this morning, we will follow my injunctions. All of today will be a matter of triage. We'll be triaging a set of very important topics. And there are some that I cannot leave this room in good conscience without exposing them to you. And we're going to have to go move quickly, move light. We're not going to always have the chance to tie things in as firmly into this model as I would like, but we will try, if possible, to use this as our center, perhaps for some forays to and fro. And so we're gonna focus on fairly light coverage, but substantive coverage of a set of important issues, without dwelling nearly as long as we did upon the topic of quality of life elicitation or quality of life representation. Okay, so are you ready for your first exercise? Okay. Dylan is proactive, engaging in assistance. Okay, so we're going to take this model. Maybe you want to save it. Do save as. I think AnyLogic sometimes doesn't let you do save as unless you modify the model slightly. So you could just move something and then you can do save as. Thank you, Dylan. And you might want to save it under a different name just so you have some point of reference. Alternatively, it is on the Google Drive in the example models area. So here we are. Here's the SAC. It's a SAC site on Google Drive. Example models built during boot camp. It stands before you here. Weight and diabetes SAC. So, but I would tend to save it so that we can roll back if we want to. Okay, so I'm going to save version 2, something like that. Great. Okay, ladies and gentlemen, it's good to save versions of your models over time. It's even better to use things like version control systems like Git or Subversion, those to whom know what I'm talking about. But what's really important is with your models that you save them away periodically and you save different versions. And if you ever do analysis with one version you may be interested in later, don't just overwrite it. You might want to go back and recreate those things later or recreate variants of them. So save a new version with a new name. And maintain that information about which version of a model given output was created. If necessary, maintain it in a lab notebook of your own. That's very important so you can go back, you have recourse to that exact model, those exact scenarios. Mark my words. Okay? Great. Take it from an old modeler. Okay, so what we're going to do here is we're going to rehearse something that you saw about a day and a half ago, quickly, while I was gone from the room. So we're going to put in place a network for these people. We're going to put people in a network, and then we're going to use that network to affect behavior. Okay, so ladies and gentlemen, could you tell me, how do I go impose a network? Suppose I wanted to connect people within this population. I'll make it a population of size, let's make it of size 250. This would be in the baseline. I'm going to go make it a population of size 250. Suppose I wanted to connect people on a small distance-based network so that two people, person A, person B, are connected if and only if they lie within a certain distance of one another. How would I do that in AnyLogic? Anyone remember from that exercise? While I had left the room to complete my morning run. Anyone remember? How do we do that? Okay, perhaps we need a bit of calisthenics. Okay, so go to who takes care of imposing networks? Main, indeed. So go to main, go down main, and by selecting main, make sure it's selected here in properties, and then I'd like you to scroll down and there'll be an area that says space and network. I realize I need to restrain my voice. I woke up at 1 a.m. which is about waking time back in Saskatchewan. And I realized I'm not sure I could have spoken. I was terribly, terribly hoarse. Fortunately, it recovered, but that's not a one-way street. So I better speak lightly, but I won't carry a big stick. Okay, so in Maine, if you grab it and you scroll down here, you will find an area where it says network type. And I'd like you to select distance-based network. Do you see that? So what did I do again? I want to impose a network on people where two people will be connected, A and B will be connected if and only if they lie within a certain distance of one another. So I go to Maine. I scroll down in the properties of Maine to this area that says space and network, and you may have to expand it like this. Then I went down to network type. I selected distance base, and I'd like you to make it a connection range of 75, no less. Okay? Okay. Now, I'd like you to run this model. Do you think we'll see the network? Why not? What do we used to do? So here's our population. It lies before us. Are they connected in a network? Turns out that they are. It's just not shown. How can I make it show? Sorry? The link, yeah. So where is the link described for a person? It's in the connections of the agent. Don't be fooled. There's a connections thing for Maine, but don't be fooled by that. That's present for consistently for all agents. Go to person, go to connections here, and I'd like you to make it, go select connections, and then I'd like you to go down to the area where it says animation, and I'd like you to select draw line connecting agents. Do you see that? So how did I do that? Let's go rehearse everything I've done to this point, because some people may still be waking up. Okay, so additionally I went to Maine, I scrolled down to space and network, and I selected distance-based, and I made it a connection range of 75. After that, I double-clicked on person, opened that up, I selected connections, I went down to animation, expanded it, and I ticked the box that says draw line connecting agents. Are people comfortable with that? Okay. Nolian assistance stands ready. Let us now run our model. What should we see? Anyone? Should see something like this. Do you see something like that? Okay. So, we now have a network in place. Let us now, ladies and gentlemen, put in place a representation of behavioral influence spread over that network. Now, this notion could be captured in a manner similar to how you captured things the other day. Do you remember when you had agents interacting 2 days ago, when we had to leave the room and you had to do that exercise? How did they interact? How did they influence each other? With a message. That was a discrete mechanism. Sort of, I'm influencing you in a discrete way. Perhaps it's untoward utterance. Perhaps it's you encounter me exercising even in the rain, and you're inspired by it. Perhaps you see me eating a crisp apple, and you're inspired. So these are cases that we might approximate, abstract as kind of incidents. They're events that we view as kind of more or less instantaneous encounters. By contrast, ladies and gentlemen, there are some sorts of influence that are more slow-going, more persistent, more ongoing, that can lend influence as well. Think about a family's environment and the influence of the parents on their children's attitudes. So we're going to capture that sort of influence here. Okay? So watch this. Ladies and gentlemen, building on our aspiration, building on the acclamation for us to build hybrid models, I would like to add in a little bit more hybrid mechanism here. And then we will reflect on it. Okay, so I'd like you to go to the palette, and I'd like you to go to the system dynamics area of the palette, and I'd like you to drag in a stock called physical activity level into person note. Where have our stocks? Till now, where have our stocks lived? In Maine. But remember, these different mechanisms, whether they be events or state charts or stocks and flows, these things can live in Maine, they can live in person. Many of them can even live some of them can even live in an experiment. But in any case, Maine and person, no problem. So don't be caught up in your understanding that state charts are only things for people and Maine can't use them. No, it can use them just fine. If you want to capture the seasons, which exhibit pronounced variability in my neck of the woods, you could do so in Maine. Okay, so we've added a stock, and now I'd like you to drag in a flow into that stock called change in physical activity. Okay? How do stocks change? How do stocks change? Through what? Through their flows. So this is the mechanism by which a stock will change. Now, we saw a little exception to that yesterday, whereby episodic cost just banged the stock up. Boom. It changed suddenly. And such is the privilege afforded to us by a hybrid model. But for the most part, the stocks in this stock will only change by its flows. Now, for physical activity level, ladies and gentlemen, I'd like you to go put in, for physical activity level, a draw from a uniform distribution between 0 and 1. Now, if I had more time, I would introduce an SES index variable that captures the SES level of a person. And I would have the physical activity level initial value be dependent on the SES index of a person. So someone with higher SES index would have the opportunity for higher levels of physical activity, and converse is also, and lower SES with less so because of lower walkability, more adverse situation with respect to crime, etc. But right now we're just treating this because we have many miles to cover today. I'm just treating this as being more or less independent. I want to concentrate on the heart of the matter. Okay, so now, ladies and gentlemen, I'm going to drag up a variable that's going to be called target physical activity level. Yes, it's a dynamic variable. Thank you. It's a dynamic variable here. In some quarters, this would be called indicated physical activity level. It's a level of physical activity level sort of that's currently towards which the person is slowly being drawn. Okay? Now, we're going to hitch this up, wire it up, and then we're going to fill what this is in just a minute. For now, we're going to leave that, and we're going to drag a link to the change in physical activity. Okay, just like that. And now we're going to add a parameter called time to adjust physical activity level. I'll call it mean time to adjust physical activity level to be a bit clear about it. It's the average time to sort of adjust. So, people's physical activity level, in light of social norms, it doesn't change immediately. It takes time. if you're surrounded by a new set of people or extremely physically active, maybe it takes a couple months for you to also be drawn into some of their physical activities, to be inspired by it. Okay? And ladies and gentlemen, I'd like you now to hitch up 2 additional links. One, a link from this parameter to the change in physical activity level. And finally, a link from physical activity level back to this change in physical activity level. Okay? So here we have it. And what this is going to be, what we're going to have here is a regulatory feedback. What do I mean by regulatory feedback? Anyone? Well, it's like a feedback that takes place within our body to keep our temperatures constant. Maybe you can help back there. Backward.
Actually, one thing I want to do here is the display is incredibly tiny. So can we need to move this table off to the side so you're not sitting in front of the screen? And second, I'm going to move that projector just here.
Sure.
Space. So let's take a minute to do that.
Sure.
We'll just make like.
Oh, okay. Yeah, sure. I should have brought some binoculars. Okay.
Let's do this.
Okay.
Okay.
Thanks, Dylan. That's a big help. Big help.
And again, I need you to move this. We need to move this table over there a little bit. So if you can take off the water and then we move the table.
Oh.
Because otherwise, then you're in front of the screen and it's hard to see.
Oh, I see. Yeah. Okay. 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 Okay.
Oh, sorry, that was my fault because I was on top of it.
Okay. Great.
Oh, and then we lost it. There we go.
Okay.
Okay. Just here. Oh, there we go.
Okay. Pretty good.
Yeah, more or less. A little bit better at the back.
Okay. Okay, so this is what's called a regulatory loop. Just like our body has a set of mechanisms to keep any number of systems in balance, keep us securing enough nutrition, burn fat when we need extra energy, loops that impel us to feel thirsty and go get water when we're thirsty, when our body needs water, loops governing the amount of salt within our body, factors governing our thermal balance to keep our body at a safe temperature, even in adverse weather conditions, great heat or great cold outside. This is a regulatory loop like this. We're going to basically see this adjusting this physical activity level so that it tracks this target physical activity level, although with some delay. It will tend towards this target physical activity level. So we're going to put in place a mechanism here to do that, and then we're going to describe what this target physical activity level is. Okay? So, ladies and gentlemen, I'd like you to go here. For mean time to adjust physical activity, I'd like you to set it to 0.5 years. So 0.5. Okay? Why do I say that's years? That's the time unit of the model. For change in physical activity here, I'm going to make it here, it's going to be target physical activity level minus their current physical activity level divided by the mean time to adjust the physical activity level. Now, this may seem a bit mysterious, but the idea is the bigger the gap between this and this, the bigger the gap between the target and physical activity, the faster physical activity will be changing. So if target is far above this this currently realized physical activity level, then the flow here will be positive or negative. If target is much larger than the current physical activity level, will this be positive or negative? It'll be, sorry? So if this is much larger than this, will this minus this be positive or negative? Positive. If this is much larger than this one, this will be very large, right? And it will tend to rise quickly, chasing, as it were, the target. If target is less than physical activity level, if the target is below the current physical activity, will target minus the physical activity level be positive or negative? Be negative. And so this will be a net negative flow, which will drag physical activity level down. So what this is saying is this is getting this physical activity level to chase, as it were, the target with a certain lag, average lag. And there's a well-defined theory of this in system dynamics. This is like system dynamics bread and butter. This is a familiar sort of pattern in system dynamics, an archetype associated with tracking something. Okay, so the bigger the gap between these two, the more physical activity will be changed, the faster it will be changing to close that gap. Okay? Okay. Now we're almost done. We're almost done. Yes, Joe?
If you were Mark Heffernan, you'd do this slightly differently. You'd say, listen, this is a goal-seeking behaviour, and you'd explicitly put the gap in the model as an extra variable. So you'd have physical activity level minus target physical activity level and a GAP gap dynamic variable. So instead of looking at the equation, people can then see the gap is what's driving the change in the flow. And then you can go and get all those wonderful signs on the London subway and say, mind the gap. So that's your job, to mind the gap and be goal-seeking behaviour. Again, making it the equation here, which has got two concepts in it, tease it out so it's visually represented as those two specific stages.
Okay, I like that. Let's do that. Thanks, Jeff. That's very helpful. So let's go take a dynamic variable called.
Before you go on.
Yes.
That sentence, does it have a semicolon at the end?
No.
You can't actually see.
No, there's no semicolon because it's computing a value. It's not telling it to do something.
So that's activity gap, I guess, isn't it? Gap.
Sure. Activity gap.
Yeah.
I like it. Okay. So, ladies and gentlemen, what we're going to do is have a separation of concerns, parse that thing into two pieces as befits clarity. Sorry. Here's activity gap. Hey, come on. Get back there. Okay. Sorry?
Circle to grab hold of
Yeah, what are you putting in the middle there? What's that
Dynamic
thing?
variable.
This is a dynamic variable. Yeah. That I drag then. Yeah. And now, I kind of, yeah. Gap is, yeah. It's maybe the least bad of word for it. Activity gap. So if activity gap is high, that means the target will be well above the physical activity level. If activity gap is 0, they're exactly matched. If activity gap is negative, that means the target is well below the physical activity level. And physical activity level will be heading towards this target. So we have this activity gap. And who could tell me what's the formula for activity gap? Well, we wrote it before, didn't we? Target physical activity level minus the physical activity level for the activity gap. I like that. Just like that. And you don't even need the parens now because you don't have anything else. So it's just one minus the other. Does that make sense?
No.
Okay. So this is the difference between the target and the actual. Right? So So maybe you're aspiring to a certain level of physical activity, but your actual physical activity level is below that. There'd be a big gap between the two. If, on the other hand, your actual physical activity matches your aspirations, it will be 0. And if the target is well below your current actual physical activity level, it will be negative. In other words, you'll have more physical activity than you're aiming at. So this is a gap between the target towards which we're heading and the actual that's realized. So this is this activity gap. And this target, we're going to come back to, but that's going to be affected by our neighbors. That's the thing that's affected by the people around us, by the environment in which we're located. And our behavior, as captured by the actual physical activity, will slowly adapt to that. Okay? So we have this activity gap, and then this change in physical activity here is just what? We're going to replace this first part by what? Activity gap. Activity gap.
So Nate,
Yes.
activity gap is a dynamic variable.
Yes.
It changes.
Correct. Yeah.
Target physical activity though will be constant, and so what?
No, this will not be
Will
constant.
not be constant.
No, we're going to be setting that in just a minute. That's going to need to vary based on who's around us and what their physical activity level is. Okay, so the mean time here is 0.5 years. Oh. The mean time is 0.5 years. This physical activity level had an initial value that's uniformly drawn between 0 and 1. The activity gap is given by the target minus the physical activity. This is this mismatch between kind of the what is being implied by the influence of people around me in my current one. So, I've suddenly been thrust in a class of enthusiastic yoga practitioners. And every morning they go down to Bondi Beach for yoga. And over time, I'm going to end up being influenced by this in a significant way. And it may ripple through to my physical activity level. But it's not going to be instantaneous. It's going to take some time for me to learn about it, for me to develop comfort, for me to develop a relationship of trust and reciprocity with them, for them to be integrated into my social support network, and for me to then put that into place. So the idea here is that we have some current influence that's drawing me in a certain direction, and then some actualized level of physical activity that's my current level. Does that make sense? Okay. Are people comfortable? Do people have this structure down? Okay, so what we need to fill in is this target physical activity level. Are you ready to do that? And that's the final thing we'll be doing here. Ready to do that? Okay, so ladies and gentlemen, there's many ways that we could do this.
So are you on target physical activity level?
Am I on it?
Yes, that's what you said to go to, target.
Yeah.
Okay.
Yeah.
So you were in person and
Yeah. So I wanted to give to sort of preface my actions here with some remarks. So there's several ways we could accomplish this. We could accomplish it in a single line, and I'm sorely tempted to do that. Or we could create a function that would be nicely named and would make it arguably a little bit more transparent. I'm inclined to do the function. Are you okay with that? It'll be a 3-line function. 4-line function. You okay with that? Okay, let's go do it. Okay, here we go. So we're going to put in place a function. Where do we go for functions? Agent, and let's put in place a function. And it's going to be called physical activity level of network connections. Let's call it mean physical activity level, or average physical activity level of network connections. So this is going to be the average of the physical activity levels of those around me. Does that make sense? So I'm gonna have this function compute that.
Of what, sorry,
Of network connections. So it's called average physical activity level of network connections. That's for my particular social network. What are their physical activity levels right around me? Okay. So, ladies and gentlemen, let's go build this function then. This will take not 5 minutes. Okay? So we clicked on it. This does it do an action or does it return a value? What do you think from its name? Returns a value. It's going to return the average. It's not going to take any arguments. It doesn't need any information to do its job that we have to give to it. And now we have to write the body of the function. So this is what I'm going to say. Okay. First, to explain what I'm going to say is, you'll notice each person is associated with a set of connections. Remember we went to that a few minutes ago just to set it so it'll be displayed? Okay, so I'm going to refer to my connections. Okay, here, watch this. Okay. If connections dot size is greater than 0. In other words, if I have any connections, if I have at least one connection, right? Alternatively, maybe to be even more specific, you say if it's greater than or equal to 1. So it's like, as long as I have at least one connection, right? Then I'm going to return this following thing. Ready? Are you ready? Return average. I'm going to take an average over something.
what's collection mean?
It's telling you it needs some collection of agents over which to take an average. You can look these things up in the help system, and there'll be information on them. Okay, so for these connections, okay,
Putting connections, not collections.
This was just a help.
it was just to help. It was just it tells you what it's expecting there, and connections are going to be a collection. And I'm going to say connections dot get connections. This is going to be a collection of connections. Okay? And
You moved the any logic window
up, yeah,
Yeah, it's
yeah.
the new setup is good, except that you're now in the way of the code.
Okay. Maybe I should get back on my knees.
I suppose they don't need to see the top bar of it. We could
Yeah,
just like link it.
we don't need to see the top, we just need to see what you're writing.
Okay, that's a good idea.
You guys are all okay. I'll do that. We all okay with that?
Yep.
Can we infer what he might be doing up at the top bar?
That's all fine.
This is good?
Good. Great. Okay, so we're going to do this average over the connections, and you'll notice that this average needs a collection. And that's the set of my connections. And then I'm going to do for each person in there, I am going to take their physical activity level, person dot physical activity level, okay? Otherwise, return 0. Okay, it's not. I thought it was called physical activity level. No, physical activity level. Yeah. So okay. Oh, I know. Okay. Fine. Sorry. We need to do one more thing there. Fine. So let me go back to the properties here. Yeah. Okay. Right. Right. Yeah, there should be a better way to do that. Okay, fine. Person dot physical activity level. Yeah. Man, that shouldn't be necessary. Oh, I know why we have to do that. Never mind what I just did. We can do it the correct way. We just have to do one thing. Excuse me. So write it this way, just like I'm doing it now. We'll just have to do one thing to make it work. We have to do it over at connections. So if I have, as long as I have connections, this shouldn't be return 0. This should be, return physical activity level. Return my current physical activity level. Yeah. So as long as I have any connections, I'm going to take the average over those connections of their physical activity level. If I have no connections at all, my target physical activity level is just going to be my current one. Now, there's going to be one thing you've got to do before this will build successfully, and that's going to be over here. How many people are ready to have me do this? Okay, how many people would like me to wait with this for a little bit more? Anyone like this on a big screen? I could put this code up on a notepad, put it up in front of people, something like this.
A couple new lines.
Thanks. Yeah.
I think we're going to view. You go to view up at the top, there's a word graph.
I don't want to do a word graph. I don't. It just looks confusing.
Okay.
So what this is doing is it's taking for my connections for each person in turn, it's getting their physical activity, and it's taking the average of that if I have any connections. Otherwise, it just returns my physical activity, my current physical activity. People okay? Okay. Okay, run. That's it. Oh, sorry. One final thing. This thing has to call the function. So we have to make target physical activity level, call average physical activity level of network connections. Come on, still looks a bit fuzzy to me. Maybe we could adjust it a little bit more.
There we go.
Okay.
I think it's about as sharp as I can get.
Yeah, I think that's a little bit better. Okay. Okay, any questions about that right now? Should we run it? Should we run it? Okay, so ladies and gentlemen, this is a hybrid model where each agent is evolving according to system dynamics. So let's do according to the system dynamics beyond its state chart. So let's run this. Sorry, I told you. We have to do one thing. Go over to connections, and for agent type, change it to be person. So we have to go over to connections here, select connections, and where it says agent type, make it person. Okay? Okay? You ready with that? Ready or not? Return an error?
Yeah.
Even after changing the connections? Change it person? Okay.
Yeah.
Is it still an error?
Changing it, agent type to person returns error.
Okay. Who needs help? Okay.
Oh, this is called half-hour
Huh?
But the connections thing, where's that?
The connections is right there. Yeah. Okay. And then is used but not expected. So Okay, so this is not used, but it's expected. So this target physical activity gap, it's being, can you go click on this thing? Yeah, okay, yeah, so this thing needs to be replaced. This minus that is now just referring to target physical activity gap. No, all the, just remove it to the divide sign. They're not including the divide sign. Yeah, move everything in parentheses.
I think you just click on space.
And then I put this.
Target physical activity gap. Okay? So, who else here needs help? Okay? So it's that, okay, it's not used but expected. Physical, because it's a thing called physical activity gap and then target physical activity gap. Where's this? Can you double click on this? Okay, scroll over there. Physical activity level. It's okay. Oh, yeah. Right. Yeah, you don't need to. So this guy doesn't need to connect to here anymore. This one can be gotten rid of. Yeah. You can get rid of it. Yeah. There you go. Okay, now try building it. Okay. Meantime is used but not expected. So, this guy needs to go to this. Yeah.
We need some dynamic variable activity gap, but I can't see it.
There it is. Yeah. So this one should be dragged to there then. Yeah. Yeah. No. To this guy. To the X. To the cross. Yeah. There. Okay. Okay. And now yeah. That should be greater than right now.
It doesn't have any space. That's space.
Yeah. Okay. I think that's all. Okay. So who else needs help here? You need help? Okay. Okay. So this guy is no longer needed. See, mine doesn't have one anymore. There. And okay. Give time to adjust physical activity level. Yeah. To adjust. So it looks like it's not used but expected. So it looks to me like. Oh yeah, you got this twice there. Okay. Okay, now it's happening. Okay, who else needs help here? Help? Help? So, activity gap. So this is, you're looking at this guy here, right? Oh, yeah. So this guy is needs to go back. He's back by yeah.
You have this target and then the target actually, and then the gap between the if that is just happening, then the target is what actually every time you look this, it actually captures the gap between the target
TARG and the control space. Yeah, and minus the physical, physical.
Which connected it to the main,
Yeah.
but not to the main node.
Yep, that's it. Okay, so why don't you,
Now I'm thinking about it. No, I just said bless you.
Yep.
Oh,
good.
Sorry about that.
Okay, who else needs help?
Mine is still in there.
Okay, it built successfully. Okay. So, okay, so ladies and gentlemen, you should be able to now run this model. And, well, the picture won't look different because we haven't wired that up to other things. What you will see is physical activity now is fluctuating for a given person over time. Why is this changing? Why is it changing for different people? Why is their physical activity level changing? They're influenced by other people around them. And if we had time, we could go and we could, oh, I'm sorely tempted to do it. Okay, here we go. Let's show it visually. Let's show it visually. So, yeah. Yes.
An interesting thing that's come up.
Okay.
So you've done your division.
Yes.
But there is a very weird scenario, a very rare scenario, where your target physical activity level and your physical activity level will be exactly the same
Sure.
right now to the decimal point.
Sure.
So you're having division by 0, which is not a number.
No,
right?
no, they're in the numerator.
Can I see?
Sure. Yeah, here's activity gap, which is one minus the other. And this thing here is activity gap divided by this. This is a constant.
So we must have them backwards then. Okay.
Activity times exactly the same.
Also, check the mean time to adjust physical activity level even there.
Oh,
yes.
Mean time, yeah. Oh, right. It's exactly the same.
Yeah, make sure the mean time is non-zero.
What was the value?
Point 5.
Okay, so
Yeah. Yeah. So, okay, so folks, the final thing we'll do here is, if it's okay, what I'm going to do is I'm going to go and let's go over here to person, to their presentation, and go to shape body. Do you remember that? Okay, now watch this. I would like to set their, we're gonna switch things slightly here. We're going to set, right now it says fill color to be color. Do you see that? I'd like to actually make that the line color. So make line color be color, and we're going to put something else for fill color. Line color will be fill. How do we do that? We have to make it go from equals to this kind of recalculate one, right? Right? So we have to make this color. And I'd like to make the line width thicker. Let's make it a bit of a thicker one. Like, let's suppose the 3 point. We're going to pick the line width here. The fill color, by contrast, will be an expression that I'm going to tell you. Are you ready for it? LERP. Okay, it'll be a LERP between, if it's low, if it's 0, it will be red. Otherwise, it will be green, and it will be, and it will be based on physical activity level. So it's called LERP color. Yeah, LERP color and physical activity level red, green. So what this is doing is it's saying take physical activity level and use it to pick a color that if physical activity level is 0, it will be red. If it's 1, it will be green. So the more high physical activity they are, the more what color they'll tend to be. And the lower physical activity, the more what they'll tend to be. Red. So let's be clear what I'm doing. So for the line color, it's just the same color variable. Remember that? For the fill color, it will be this lerp color. Okay? Networks. Networks.
So what does lerp mean?
Mumble. It's an interpolation. It's a linear interpolation. Why it's called lerp, I cannot explain that at the moment.
Good idea. I'll double check it.
Yeah.
I have missed a step.
Okay.
Because I've got all my physical activities, I don't think they're changing because the initial values are all 0.
The initial value should be uniformly distributed between 0 and 1
Right, yeah.
of physical activity. Okay?
Yep.
Okay, does anyone want this on the board longer? Okay, do you want to run the model? Want or not? Okay, let's run it. What are we seeing there?
So should you have a semicolon at the end? A lerp colon?
No. This is computing a value. It's
Maybe because you have spaces?
nope. It shouldn't matter as long as they're not spaces in the middle of a name, or they're not spaces in the middle of an operator like greater than or equal. Okay, so what are we seeing there? Changes in physical activity. Okay, yeah. So there's people. Man, it looks like this one's pregnant or something.
Got something out south.
Okay, these have a uncomfortable mummy aspect to them. King Tut.
Your line's a bit fat.
Yeah, the line is a wee bit fat. Okay, but this color here is encoding differences in color, and there's some mixture between green and red, and it tends to homogenization. Well, I'd love to spend more time in it. We could have it click on it and change the physical activity and see the effects, but we've got miles to cover. So I'm going to leave that for now, but what we saw there is a persistent network connections that shape someone's physical activity level such that it tends to follow the physical activity levels of neighbors. So there's some capturing of sort of social influence with a delay. Okay? And you can go in when you're browsing it at an individual level, and you can actually see how it's changing over time using this sort of thing. And you'll see there's significant discontinuous dynamics associated with it. Okay, for some people going up, some people going down, bringing them in line with their neighbors. And with that long delay, there may even be cycles over time for the various people as they sort of interact. Not perfect, but it shows something about the power of networks and how they can be combined with hybrid modeling. So, ladies and gentlemen, let's close that and let's